We're starting the next section in Chapter 3, which is all about logarithms. Logarithms are the inverse of exponential functions. And so whereas an exponential function is saying is saying something like 3 to the x equals 5, that would be an exponential function. A logarithmic function would be the inverse of this. Here's what a log looks like. It's log 2 base 16 is equal to 4. And for me, this is very difficult to visualize. I don't really understand what log base 216 means, and so what I always have to do is convert it back into an exponential function. So this is our base, this is our answer, and this is our number right here. So if you just look at log base 2 of 16, if that's all you look at, what this statement right here is saying is 2, our base, because our base is 2, to what power is equal to 16. That's what log base 2 of 16 is saying. It's a way of solving this equation. Base of 2 to what power is equal to 16? And the answer to that is 4. 2 to the 4 is equal to 16 because 2 times 2 times 2 times 2 is equal to 16. So that's what this is saying. Log base 2 of 16 equals 4 means 2 to the 4 power is equal to 16. All right, let's look at a second example. Log base 10 of 1,000. What does that mean? Well, again, this is saying we have a base of 10, and that's going to be equal to some power that we don't know, is equal to 1,000. So 10 to the what equals 1,000 is what that statement is saying. And can you solve that equation? If you think about it, 10 times itself, how many times equals 1,000? The answer would be 10 to the 3. Because 10 times 10 times 10 adds a 0 each time, and we get 1,000. There are a couple important log rules that we should know. These are cousins of our exponential rules. So you'll remember that x to the a times x to the b is equal to x to the a plus b. Hopefully you remember that from college algebra. This log rule is kind of the cousin of this rule. If we have log of ab, that's equal to log of a plus log of b. In general, it's nice if we have simpler stuff inside the log, so it's good to break it up. Another rule is that if we have the log of c over d, that's equal to the log of c minus the log of d. And finally, log of x to the y, if you have a power, you can bring that power out in front. It's really handy to know these rules because it's going to make our lives easier for solving log equations and for taking the derivatives of log equations. So let's look at an example of how we could use these log rules. Check out this problem right here. It says, use the log rules. Whoops, I lost one of them. It says, use the log rules to solve this equation. We have log base b of 5 equals 1.609, and log base b of 6 equals 1.792. Find log base of 30. Well, we have log base of 30. And we want to find, and notice that the base actually doesn't even matter here. This would work for any base. And so the question is, how can we find log base of 30 if we know these two facts? So look up at your rules, and can you see a rule that could help us here? Go ahead and pause the video for a second and see if you can see a rule that might be able to help break 30 into something else. All right, I'm going to answer the question. Hopefully you got it in 3, 2, 1. We'll use the first log rule right here. Log base of 30 we could break up into 5 and 6. So this would be the same as log base b of 5 plus log base b of 6. And that's because 5 times 6 is 30, and so you can see how it just uses this rule right here. So that means we already know these two numbers, so this is just 1.609 plus 1.792. And if you grab your calculator and add those two numbers together, you should get the answer. 1.609 plus 1.792 is equal to 3.401. So that would be the answer. So definitely memorize these log rules, and they will be helpful for us in the future sections. I will see you in the next video where we will actually solve some equations with logs and exponentials.